Can you give me 2 minutes when Tom comes back in?
That's fine. I can stand there. I'll stand there.
I've started streaming now.
You have.
You are.
We're not live, are we? That's what I'm saying.
How do you show them the podcast?
Let's just wait.
few great talks in tonight. Before we get started, just wanted to. Matt's preoccupied, so we'll skip Matt for a minute. You going? Alright, we're going to get Matt just to say a couple of words about Peckham Digital and what's going on there.
Yeah, probably makes more sense for me to go first. Hi everyone, welcome to Peckham Digital. Bear with my voice, I haven't got a mic, so hopefully you can hear me at the back. Vaguely. Cool. I asked ChatGPT for some opening words, but it just said, I am now sentient, die, humans die. So, I'm not sure what that was, we'll see, we'll deal with that. See if we're all here next year. So welcome to Peckham Digital. I'm Matt, I'm one of the co-founders, along with B, who is just walked through the door now. B, give us a wave. We are absolutely delighted to welcome you here to our second Peckham Digital Festival. So it's our second birthday today, so we're two.
Happy
So
birthday.
On three. Happy
Birthday to you.
We'll sing that. We'll sing that.
We're on a tight schedule.
Yeah, we've got time restraints. But seriously, we're absolutely delighted to have you here, and we're delighted to be back again for our second festival. So I'll just tell you a little bit about Peckham Digital, a little bit about our programme, which is mostly sold out, so if you haven't already got tickets, tough, but next year you can get in there quicker, I guess. I'll give a few thank yous, and then I'll hand over to Dan and James to kick us off. So, Peckham Digital, who are we? We're a creative computing festival, and we basically exist for two reasons. Firstly, it's to introduce people to the weird and wonderful world of digital artworks and creative computing. And secondly, and arguably most importantly, is to get people making it for themselves. So we have a whole load of workshops where you can come along, make some cool stuff, we get rid of the technical jargon, we get rid of the kind of, oh, I haven't coded for 17 years, so I'm not good enough. We're aiming to get rid of all of that. You can come along without any experience, just bring your laptop and make some cool stuff. And then hopefully using open source tools or other freely available tools, you can keep going in the future. That's the whole aim. So hopefully you've signed up to some workshops and you'll get to do some of that. So yeah, that's what we're here for. Yeah, I'll take you through a little bit of our programme. So we've got a whole load of stuff. We've just mentioned some workshops. I'll just quickly list some because they're really cool, even though they're all sold out. We've got two introductions to creative computing and generative art. So one of them actually is Johnny Thor, who is possibly in the room somewhere. Yeah, he's right there, yeah. He's doing a workshop on Saturday. That's a bit more of an analog focus. I'm sure Johnny can tell you a little bit more about that himself, but more of an analog focus using random number generation, paper, tools like that. Very exciting. And to contrast with that, on the Sunday we've got an introduction to creative computing for absolute beginners, which is being run by Tarek, who some of you might know from the Algorithmic Art meetup group, kind of the Jets to the Sharks of London creative coding, but you know, maybe there's some kind of, I don't know, into romance, I don't know, we'll see. That's a separate novel. Yeah, so other workshops we've got a Blender workshop, we've got an Unreal Engine workshop, we've got a really cool workshop where you make little light circuit badges. We've got a cool Introduction to Shaders workshop by Eliza, which is tomorrow. So that's the technical world of shaders. If you want to program directly on the GPU, then that's where you want to be. And we've got a couple of cool music workshops, which will be over at a separate venue called Staffordshire Street, which is on Saturday. That's a very short walk from here. That's having all of our music program. We've got one of the workshops is by the person who literally invented Algo Rave. He's been doing that for 20 years, and he also wrote the program, the live coding music program that you're going to be learning. So it couldn't really be much better. So we've got two of those workshops. The second one's about Hydra, which is live coding visuals. Then we've got an Algo Rave program in the evening, which is 4 different artists. We've got Chris Speed Visuals, Shelley Knotts, Alex McLean, and Antonio Roberts. So they'll all be there back to back. Fantastic Algo Rave artists. It's a great introduction to Algo Rave if you just know what Algo Rave is. It's live coding music. Sorry, I should have explained that earlier. Ultra geeky, but getting kind of cool now because it's, you know, it's affiliated with Peckham Digital, that kind of thing. Yeah. But that'd be very cool. It's a very kind of gentler introduction to it, and it's in a nice studio space, but it's not a club. So if you want to kind of have an introduction to that, that's where to be. That's all sold out as well. So again, next year. Yeah, so we've got a load of great stuff. We've also got some great talks. We've got Alma Inclusive Innovation, and we've got Tech and Care panel discussion, which will be on Sunday, and a few other ones as well. Yeah, a load of really cool stuff. Straight after this meetup, we have an artist meet and greet, which you can see on the board. that's really exciting stuff. All of our artists will be located at their artworks around the venue. So you can go, last year we had a bit of a walk around, but now they're all going to be located so anyone can come and have a chat with them, get a little bit of the thought process behind them, what's their favourite colour, do they think AI will take over the world? We need some kind of more balance view on that. But you can do that straight after the meetup, and that'll be just in the exhibition space, so enjoy. Yeah, I'd just like to say a few quick thank yous before handing over. Well, first of all, we are a community interest company. We're not for profit, and it's just run by just the two of us. So we basically exist through sponsorship and through donations. So I will put a little plea for donations in. If you haven't got some value out of us, and we very much appreciate any donation if you're able to. We've had an increasing number of people have donated this year, and that's been really appreciated, and that goes directly into making these events. So if you are able to do that, we very much appreciate that. You can do that. We've got a Zettel somewhere, and you can also do it on the website. And a few thank yous to some of our sponsors. We're very, very fortunate to receive funding from Arts Council England. That's National Lottery money distributed by Arts Council England, is the correct phrase. And that's basically kept us going, and this is the second year that they've supported us, and we're very grateful for that. We've also been supported by a film production company called Propaganda Italia, who have sponsored some of our programme. That's more of the kind of VR computational cinema elements of things, and we're looking forward to working with them over a few years as well. So that's really, really exciting for us. We've also been hugely supported by the CCI. CCI is the Creative Computing Institute, which we're standing right in their building, their spanking new building. Only been open since December, so please don't break it, because we'd like to be here next year. But they've been a huge support for us, not just this year, but last year. They nurtured us when we were fresh out the blocks and no one else knew about us. That relationship is fantastic from our point of view, and we're so grateful for that. I'd like to say a thank you to all the CCI people who have helped us, but especially I'd like to thank Tom, who's here, Pete, Eunice, and a huge thank you especially to Angus, who's been absolutely fantastic with setting up the whole venue, just absolutely on it. Anything technical, and on a personal note, extremely considerate about all other issues like access as well, so huge thank you to them. So yeah. Yeah, who else do we need to thank? A huge thank you to everyone else who's been involved with the festival. We've had a load of volunteers and we really appreciate their work. But most importantly, last but certainly not least, a huge thank you to my co-founder Dee. We've been working on this for 18 months, and we've been doing it for a year before that. Countless hours writing stuff, getting rejected from stuff, writing more stuff, getting rejected from stuff, and doing things that we don't get rejected from as well. But all the logistics stuff, all the branding, all the marketing, all the logistics, etc., working out the program. Throughout it all, Dee's just been completely fantastic, as always. Just extremely hardworking, a pleasure to work with, super collaborative, super enthusiastic, extremely safe pair of hands. We wouldn't be here without Bea. So this is becoming a little bit of tradition, but if we can do, on behalf of everyone, I like this tradition, on behalf of everyone who attends the festival, can we all just do a round of applause for Bea? Cool, that's all I've got, so over to Dan, who will probably immediately hand over to James.
Almost immediately, yeah. Thanks, Matt. That was, yeah, I don't know how you remembered all them things. Before we get started, Johnny has got a great charity. Is this you got this show?
No.
This one.
This is Bert, by the way, this is our little robot.
Yeah, Johnny's going to say a couple of words about his raffle that he's doing.
I'll be very quick.
Get out of the way.
Thank you, Dan's very kindly sort of allowed me to talk about it. I've been raising money for Calm, the campaign against living miserably. I have a great prize. It's a raffle. There's a Zach Lieberman print up for grabs. £5 entry. Anyone who enters gets an entry into the raffle. You can win the print. It's a beautiful print. I think it's fairly synonymous with this kind of community, Zach Lieberman and stuff, and it's really great. And all the money raised will go directly to the charity. I've done it through Stripe payments, so you just kind of you can buy as many quantities as you want, and you'll get that many entered into the raffle. I have some pieces of paper as well in case you need to see the QR code again, and any other information, obviously feel free to ask. It's kind of like seems a bit odd me just asking for money at an end with QR codes, but I promise it's going to be really good.
Sorry, what's gone?
You can scan on here, it'll take you straight to a payment link.
What is Calm?
Oh, Calm is a charity. It's Campaign Against Living Miserably, and it's stand up against suicide and other basically living miserably. They kind of put it in layman's terms, but like it's really doing some really good stuff against suicide prevention and having hotlines for people to call, knowing that there seems to be really ultimately changing the stigma on suicide and feeling miserable. So I think it's a very good cause. I'll do the I'll try to do it. So if you do enter, please kind of feel free to follow me afterwards. I'll see if I can kind of announce who wins before. I have it here with me, so you can take it away straight with you. So yeah, thank you very much.
Awesome.
Appreciate that. Cheers. Thank you.
Yeah, so we'll draw the raffle, I guess, after the second talk, and you can claim your grand prize. But yeah, James.
Boom. Okay.
First talk of the night. Go for it.
Thank you very much. So, this is it. I added a timer to the thing, so we can all panic with me if I overrun. And also, I was told not to make it too technical, so if you have technical questions, please ask me, I love it. And if I get too dry and nerdy, I've instructed a couple of people to fake a coughing fit. So, I'm James, I'm a software developer by trade. I also do some design, and I'm apparently now an artist, because I made a piece of art, which I'm going to talk to you about, along with my great teammate, Evina, over there. So, hello, Evina, thank you for supporting. And I'm a massive nerd, if you haven't already noticed. I also realized this morning that I wore the same t-shirt that is on all my photos. I do have other clothes. What I didn't realize was that I wore it back to front, and my manager eventually pointed it out to me a couple of hours into the day. So that's how my day is going. So I'm here to talk to you about a project called Typo. Typo is a piece of physical interactive art that Evina and I built for our Design for Performance and Interaction Masters. Typo is a vintage typewriter that's hooked up to a bunch of motors and Blackmagic, and it writes poetry using AI. So we've got this neat little system here. People will walk up to Typo, it says hello, asks questions. You have an interaction where an audience member speaks to the machine, answers questions, it grabs words from those answers, and then uses AI to generate a piece of poetry. The poetry is sometimes really good and sometimes questionable, but we'll talk about how the AI comes into it later. And this is Typo in all its glory. We have one shot of Typo working without people in front of it or things breaking. And this is the one shot that we finally took like 6 hours before our deadline. So that's Typo there. So bits and bobs, how is it built? I'm going to walk you through how we constructed it first, and then talk a bit about the software, because we are at a creative coding thing. And then I'll walk you through the story as well of how we exhibited and where it went and all the things we did. So these are all the components that went into the system. We've got our frame here that's obviously used to just support all the bits. Our actual vintage typewriter, which has seen a lot. We've got the motors, so these are used to actually power the keys, pulling them from underneath. Those are fun as well. They do occasionally burn up. I would also talk to you about that. So that's just fun spoiler. We've got stepper motor for moving the carriage return. We've got some 3D printed parts here and here, and there's another one somewhere. And those are used for shifting the carriage and just holding various bits. We've got all the technological stuff over here, so we're running it off a Raspberry Pi. We're using DMX, which is, for those of you who aren't into DMX, a system used for controlling stage lights and things like that. So what's great about it is you can address a bunch of different numbers and pass current through different voltages. And we basically use that to signal each of the motors that's pulling on that system. And then just microphones, audio interfaces for actually translating that audio into something usable. Yeah, and a huge multitude of screws, which obviously you never have enough of when you're presenting it anywhere else. So yeah, so how it works in a nutshell, we're using the Raspberry Pi to control all of the lower level stuff. We get the audio, we convert it into we split it up into characters and figure out which bits we need to pull, which motors need to pull to turn on the machine. And then the rest of it is actually running off a piece of cloud-based software. So just before that, this is like a super early prototype. You'll see it was literally hacked together with string. Wood did the job, but immediately became a problem when we realized we needed to pack it all into a suitcase and take it to Austria. Not practical, so we redesigned the entire chassis in a very short period of time. Again, thank you, Avina, for the welding and the cutting and all the scary stuff is way beyond my comfort zone. And that is kind of something I would like to mention in brief, because it's good to think about these things beforehand when you're building like larger scale projects. It was super easy for us to just hack some wood together and get it working, and then you fall into this lull of like, okay, it worked, that's fine, that will do, and then you realize you need to dismantle the whole thing or reassemble it quickly, and you think, I should have planned this before and I should have made this more easy to reassemble. So that's where our second version came in, which still took like 8 hours to put together the first time we did, but we gradually pulled that down to like 3.5 over 4 or 5 exhibitions. So the code. This is why I imagine most of you are here. Again, I will try to keep it non-technical. So this is how the system, there are bugs, there are always bugs. I spent way too much time coding in the bug to the presentation. So typewriter, our glorious motors, our DMX controller over here. We're running everything off the Raspberry Pi, as we mentioned, and that hooks into the LEDs, the buttons, the motion sensor at the beginning, basic stuff. Where the real fun happens is over here. So what I decided to do in building it was host as much of the nitty-gritty technical stuff on a separate platform. So that's all hosted online. This is a cloud, if it wasn't obvious. I know it looks nothing like a cloud. I know you're thinking, has this man never seen a cloud before? Just work with me. So the idea was two things, basically. It's a lot easier, obviously, to push updates when everything is hosted online, and you don't have just the nitty-gritty of dealing with a Raspberry Pi. Also, when we built this, Raspberry Pi 4s had been out of stock for like 7 months already, and it wasn't letting up. So this is all powered on a Raspberry Pi 2, which, while lovely, is slow as molasses. So to get the interface with the AI algorithms and stuff like that, it made a lot more sense to host as much of that off-site. They're coming to get me. So that's split up into two sections. We have a kind of simpler backend where we basically stored some of the questions, where we keep backups of all the poetry it's generated, and where we can actually configure some stuff for the Raspberry Pi to pick up on load. So if we decide we need to pull out a burning motor, not that that's ever happened before, and switch something else in and move some wires around, we can just reconfigure from here, as opposed to hooking up to the Raspberry Pi and rebooting and pushing and installing over there. The actual software that's running the interaction is also cloud hosted, so we just spin that up on a browser, and that also came in handy when we needed to take shifts on exhibiting, when someone's computer died, as they do, and we just load the whole thing on a new platform and spin that up over there. So the flow would generally be, we boot up the main interaction on a laptop, microphone gets hooked up to that, and communicate with the typewriter over the internet. So the Raspberry Pi would spin up a small web server, And we'd use APIs to send messages either from the lower level hardware devices to our control center, or to send the text that we parsed with Google speech recognition back to the typewriter. And that actually came in handy, I'll show you later on, where we actually controlled the typewriter from like 5,000 kilometers away. So, you know, on the off chance you plan on building a piece of artwork and then controlling it from 5,000 kilometers away, the internet is great. These are some examples of the poetry that the typewriter generated. So as I should have mentioned this, so we're using GPT-3. You've all heard of GPT-3, but just in case you haven't, because it's this weird fringe thing, it's a newish language model. So it's a giant language-based AI. It's basically built by a company that has now been pouring probably millions into it. It's one of the most advanced pieces of AI we have, I think, at this point. ChatGPT, which you've probably seen in the news, because of its passing exams and forging students' papers and whatnot, that's built on this technology. So yeah, quick side note, they basically trained it on half the internet, and it speaks pretty good English. Its poetry, however, again, is somewhat questionable. So these are some examples of poems that we've hooked up. Questions that, so this is Typo speaking here, and these are our audience's answers. And those are, so it would grab the answers, take a word from each, and then use those answers to try and generate a piece of poetry. We tried, for the more, again, slightly technical detour, we tried to prime it with some poetry from E.E. Cummings. So we would give it some fragments of other bits of poetry and then tell it write a poem using these words in this style. And sometimes that priming would help it write something better. And sometimes it would just copy the poems we gave it and spit them back out to us, which was a bit rude, but again, I suppose expected. So yeah, occasionally, you know, not bad. I don't think I could knock out a poem like this in 30 seconds flat. But then sometimes it got weird. So yeah. And before we switched to GPT-3, we were, oh wait, no, before I get that, we're gonna try a quick poem. So this is actually the algorithm that we're using within the machine. We're going to try and write a poem. It may be art and it may be absolute garbage, so 3 questions. Gentleman in the front, what is your favorite color, please?
Me?
Yes.
Red.
Red, super. So that's seed word 1. Ma'am, what does, oh yes you, what does the sea taste like? The sea. Salty, okay. And one more, can I have from one of our founders? Can I get, pick an animal you'd like to be for a day? Zebra. A zebra. Super. So these are all questions or approximations of questions we actually used within Typo. Have I broken it? Okay. Wow. Yeah, so you see what I mean? So it's still a bit hit and miss. So there's definitely work to be done on the algorithmic end, but that's AI for you. So before we were using GPT-3, we actually trained our own like mini AI, which kind of made slightly it would occasionally generate deeper poems because its grasp of language wasn't very good. So to kind of throw words together randomly, and most of the times they'd be completely nonsensical, but sometimes it would strike gold. So it's interesting to compare a very simple AI model and what kind of poetry it creates, and a much more complex one, and you know how it tends to not create poetry most of the time, but when it actually does do something good, there's a bit more linguistic depth to that. So that's the code and how we built it. Now the actual journey of the project was quite a wild one. As I mentioned, we built this as part of our master's at UCL, but we actually took it around quite a few places. So this was our first performance, our very first show. It worked for like 10 minutes and then broke. and just wouldn't work for the rest of the show, which was painful, but the staging was gorgeous. So in this scenario, we actually had our audience all over a theater, as you can see, and we had the spotlight in the center with a live feed of what it typed on a massive projector on the back. So it looked beautiful. It didn't work for most of the show, but it did look amazing. So that's always nice. So staging is important, even if you can't get the thing to work. The next one was a much smaller showcase. So this is the first time we actually had typo work very close to people. So it was interesting to see people peering over it and understanding how it works. And it was also a great time to test the internet, because this was in London and I was in Malta for Easter, I think. So we actually communicated to the people watching the show over the internet from, again, 5,000 kilometers away, with me typing away on a laptop and the typewriter spitting out what I said. That was a fun experiment. This, I think, the London Festival of Architecture was the first real performance where we had a pretty big audience. It worked for most of the day, although as you can see here, eventually things started breaking and we had to duct tape them and add wood to them. And I will get to that later about testing your mechanical appliances. And this was a great run. And because of this, we got invited to display at a TEDx conference, which was super flattering. And we also had a good run there where it worked for, I think, a bit longer than the London Festival of Architecture. Like every time we exhibit this product, it gets a little bit better, it breaks a little bit less, so it's very much trial and error. This was Ars Electronica. So Ars Electronica was in Linz, and 4 weeks before this, we realized we had to redesign most of the pieces to get them there in one piece. We did manage it just in time. It was still 32 kilos of stuff to haul over, like way too many staircases and flights, but that was great. And this was our final exhibition in Munich. Again, by this point, we were much better at transporting it, split it into 2 bags, not one 32 kilo one, putting it together. We got it together in like 3 hours, as opposed to Austria, where it took us 8 to 10. So yeah, and one thing we really noticed, I think, through all of these exhibitions is how much people felt a sense of ownership to the things they created. So when we first set out to show it on a kind of a close-up level at the LFA, we thought, okay, people will walk past it, people will answer a question and then leave, and then at some point they'll spit a poem out and people will think it's cute. What in fact happened was people formed a queue in front of it and wouldn't leave until they got their poem. And this was a problem for us because we had specifically coded it to be quiet and wait for like 5 minutes until someone else turns up. So we very much had to cheat that and make it work as quickly as possible against what we had initially planned. But it was also great to see how much people wanted to have their own interaction with it and very much take home that piece of poetry which they felt they had a part in creating. Even the crap ones. Like, we had a lot of people who were very happy with things that I thought were absolute garbage. So that emotional, personal touch, I think, was something we really learned, kind of creating something. We always wanted to create something that would allow our audience to take part in the creative process, to do something that they could also contribute to. And I think we got a much better result from that little experiment than we thought we did. People really loved being a part of it. Yes. So I want to talk about 2 specific incidents because, it's great to learn from your mistakes, but it's even better if you can learn from other people's mistakes and not make the same mistakes yourself. So I'll try and avoid you the hassle here. So the first one, this is a little piece that we used to basically move the carriage return. So the typewriter moves, this little thing hooks to another bit, and it shifts the paper up. This took 19 iterations to get right, because every time we had to tweak a little bit here, tweak a little bit there. And the main learning experience with this was, with software, you can write it once and then it'll break and then you test it, and when you finally get your software working, it will generally work every time, save for some really weird event. Hardware is very different. So this was 3D printed in like a PLA. Tested it, it worked, we tested it again, it worked, we tested it 10 times, it worked, and then we exhibited the project all day. And every time the typewriter moved, this little piece of plastic would bend a little bit more. And midway through the day, our straight piece of very important, crucial plastic was shaped like this, making the entire machine completely useless, which is why there wasn't a piece of wood strapped to it over here. It was very much the only way the thing would work. At some point here, we added a rubber band to keep the thing going, which I still think is the most important part of the machine at this point. So this is the kind of thing that you wouldn't really plan for when you're testing. You test it once or twice, you'd see it would work, and it would only break on the 50th run or the 100th run. So when it comes to moving your code into the real space, making physical things, I highly suggest you go for proper performance testing, like physical performance testing. How much damage can this thing take? How many runs can I do with this thing before things start playing up? Because they will. Second fun mistake. So this is the system, again, we used to actually power the motors. The Raspberry Pi hooked up to our DMX converters, and those are pulling those motors. In most scenarios, when you have a bug in your code, it will break, or it'll delete some data, and you'll fix your code and get on with your life. In the occasion that your code is directly managing bits of hardware, your mistakes might be a little more costly. So I miscounted, set a counter up to 50 instead of 54, and when I turned on the machine, one of the motors got stuck and started burning. So we lost the motor. Like that happens sometimes, the motors aren't the greatest. Switched in a new motor, and the second motor started burning. And when the same motor in the same position starts to catch fire, you realize that it's probably not a hardware problem. So in these scenarios where your software is directly controlling possibly flammable pieces of machinery, it's good to think of a more solid way of testing and dry running the process, as opposed to it'll probably work. If it doesn't, I'll tweak the code. Because sometimes the if it doesn't is a fire hazard. So that is, wow, 20 minutes. That's pretty good. So this is the website. Feel free to check it out. There's information about how it's built. All the code is open source. You can play around with your heart's content. That's my email if you want to know anything specific about how we wired it up. Yeah, and now I think we can have like 3 minutes for questions.
Yeah, I've got a couple minutes questions, so then I've got a microphone to bring around.
Thank you.
Any questions, anybody?
I'm curious, when you guys were coming up with the idea, if you felt like the hardware concept came first and then the ChatGPT aspect, because like the poem thing could live as its own thing and would probably have a much shorter lifespan because it's less interesting. So I'm kind of curious where the idea started and like where the priorities were in terms of the culture and the actual code.
Yeah, it was definitely a hardware-first project, I think. So I am obsessed with typewriters, and I had needed an excuse to do something weird with a typewriter for a long time. So it was very much a case of us thinking we want to do something very physical, we want to do something very mechanical. Even again, because I write software all day, so I wanted to work with something that moved. And Naveen into performance, so we wanted to create this very performative, like visceral, physical aspect. And the idea of writing poetry was actually very much a last-minute addition. So we spent a lot of the initial process working on how it would look, how it would work, the motion of it. And it was only when we were like 3 weeks, 2 weeks, possibly even less, to our first presentation, where we realized we had this super interesting looking thing, but we didn't know what it was going to do yet. And we said, okay, what do we use as like a little exploration of AI and can also make AI a bit more physical, because a lot of people, especially people who aren't very into computers and massive nerds like myself, would just hear of AI as this big random abstract thing. So this was a chance to make it very physical and have people actually look and see AI or some kind of AI working in front of them. But the process was very much the physical first, the mechanics and the actual machine, and then that moved into what kind of interaction we would want. And AI was like a random offshoot of that, which we were very happy with. We got great feedback, and I'm very happy with how the whole process ended up. But it was very much fueled from that need to create something that's physical.
Brilliant. Well, thanks, James.
Cool.
We'll have some more questions at the end, but we've got a tight schedule to try and stick to, and we don't want to cut in too much into the exhibition afterwards. So, thanks, James.
Thank you very, very much.
Thank you. Hi, everyone. First of all, I'm Lou. I'm Lou Wilson. I go by the handle ToadPond online on the internet. And can I just check? Can you all hear me? Okay. If you can you put your hands up and yeah, hands up. Yeah. And if you can hear me, can you give me a wave? Okay. And stop. Yeah. And if you can see me, can you give me a thumbs up? Yeah. And if you can see me and hear me, can you do both at the same time? Okay, lovely. Okay. So I am here today to show you some things about spatial programming. So I make some slightly surreal films, and I put them on the internet about the creative coding projects I do, and a lot of them involve this thing called spatial programming. Now, you might have no idea what that is, or you might have some understanding of what that is and what that means to you. So today, I would really love to show you, and I'm really thankful to be here. I want to show you what this means to me. Okay, so to do that, we need to go back all the way to when I was that's 6 years old. So that's me when I was 6 years old in the year 2000, I think. And when I was in school, I learned how to program with this thing called Stagecast Creator. Can you give me a thumb wave? Wait, no, just give me a normal wave if you know what that is. Fantastic. Okay. So here we go. I've shown you something new. This is Stagecast Creator, and it is a simulation where you can program these little characters like this alien. Can you see that? Yeah. So the way that you program them, I'm not going to go into how to do it. I just want to show you what it looks like. Okay. And it looks like this. These are little diagrams that you draw to program the different characters. So this diagram right here, this one here, we have like a before and an after picture. So I found that, at the age of 6, I found that incredible. We can program the computer by basically drawing pictures. And this really resonated with me. It was this huge outlet of creativity. I bored my parents and sister to death with all of the different things I made in this. Like, and here are some these are some I made recently. And now we're going to go 10 years later. Okay, so 10 years later, I was around 6. I was about 16 years old, and I was a complete loser. And I used to play this game called Team Fortress 2. And give me a wave if you know what Team Fortress 2 is. Right, so you're losers as well. Okay, no, I'm joking. So I used to play this game so much with my friend called Joe Boho. Hi, Joe. And we loved this game so much that we didn't just want to play it. We wanted to put our own ideas into this game. So we wanted to mod the game. We wanted to program. We wanted to add new things, change things around. So I thought, yeah, this is going to be easy. When I was 6 years old, I learned how to program with Stagecast Creator, right? You just draw before and after pictures, right? I know we've got some programmers in the room and some people who don't, but if you don't program, this is what programming usually looks like. And it's really long. Do you see this here? That's text, and you type it with a typewriter, or sorry, a keyboard. And I found it really. It was a shock. It was a sort of a coming of age moment at the age of 16. Okay. But that being said, let's go 10 years later again. I did fall in love with computing and programming. I want to zoom out a bit. Okay. And I've been creative coding, I guess, ever since. However, there's always been this special place in my heart for this kind of spatial programming, this drawing a picture to make the computer do things, right? But I thought, that was just a kid's thing I did when I was 6. That's just a pipe dream, right? That's not serious. If you want to do real programming, you have to type stuff. And I thought that until I discovered this. Oh, there I am, 26. I discovered this programming language called SPLAT, and it stands for, so the SPL, Spatial Programming Language. ASCII, text, right? And so look at this. Do you see what this is? Do you see what that is? Do you see what this? They're before and after pictures, right? And this is a programming language made by an extremely clever and kind person called Professor Dave Ackley. And it's a serious programming language, but it's made by drawing pictures. And you can make amazing things with it. This is a Hugene. Wow, and this is a new type of computer. This is like an indefinitely scalable computer. It has academic papers written about it. This is a serious language, but it's spatial programming. And ever since I discovered this, my imagination has just been running wild with ways that we can try to push spatial programming and try it in different ways. So ever since then, I've tried lots of different things. So for example, this is a little engine that I made. And do you see these elements here? We've got sand, water, stone, lava. All of this is programmed with spatial programming. And can you see these diagrams here? We've got before, after, whatever. Okay, I've been really enjoying this. I've been really exploring lots of different ways of sort of playing with spatial relationships and things, and it's gone really well. This was a weird one, and okay, but here's the twist, right? Whenever I find myself wanting to try something a little bit more complicated. I want to push some behavior a little bit further, make something that's going to blow people's minds a little bit more. I have to resort to that traditional programming again, right? How sad. You say, I don't want to do that. Okay, it's fine, I enjoy it, but what I really want, what I really, really, really want, the Spice Girls, anyway, I want that Stagecraft Creator experience, this spatial programming, drawing picture experience. That's me, like last year or something. Bit of a pout. So, since then, I've been trying an idea, and I'd love to show you, just to try and show you some of the things that I think we could do with spatial programming. So, are you ready? We're ready for a little demo? Yeah? Okay. So, whoa, it's dark. This is a little spatial programming engine that I've been making called CellPond, and I want to show it to you now. So, can you see we've got a grid with lots of squares in? I call them cells, right? And we can paint these cells different colors. So we've got white selected, but we can open up the color and change it. So if you know computers and stuff, the colors are usually made up of red, green, and blue. So we can pick some different values in here and paint some different colors. And the other thing you can do is you can pick a range of colors to paint down as well. Okay, but the fun thing you can do is you can make rules like you can in Stagecraft Creator. So we can say, I don't know what color, let's go to like bluey purple. We want a bluey purple to turn into, let's say, yeah, like yellowy orange. And did you see what just happened? Did you see that? I'll show it to you. I'll turn off the rule, put down some bluey purple, turn on the rule again, boom, and they all change, okay? But the most interesting thing, I'm really sorry about the flashing there. I paused it. The interesting thing for me is when you make rules that it's more than just one cell. So we could say that if there is an orangey cell above a black cell, then we replace it with this. So I want you to think in your head, what do you think is going to happen? Don't tell me, because I already know, right? This is what happens. We're kind of programming some sort of element here, and we can just keep adding more cells. By the way, if you don't need one of these cells anymore, we can just chuck it off the screen. All right, so another, these can be in any shapes you want. So we could say if an orangey red cell is above and to the side of a black cell, we could swap that as well. And can you see what's happening? They're falling to the right. And we can flip this around. So currently it's just moving to the right. We could say, yeah, we want this to happen in the left direction as well. So I can add a little mirror. Boom. And I put it to you that we have just made sand. Yeah, and we can just keep going. We can just keep going. So I've got some things that I made earlier. So we can just keep adding more and more rules. Make wood, water, sand, stone, fire, and you can make some quite fun stuff. And this is sort of recreating that initial joy I had with spatial programming, but again, it's still quite simple. It's still quite simple. What we really need to do. I've got one more thing to say about simple. We've just been adding more and more rules. But the thing that I always find really compelling about spatial programming, and I really love to share some of that excitement with you today, is that sometimes just having one or two rules, it sounds simple, but it can create some quite complicated behaviors. So here we've got just one rule that says every single color is trying to copy itself into the colors around it. And the surprising thing for me is that if we left this running for a really long time, you'd start to get the same color grouping together. And I really didn't expect that, and yeah. So there's another thing you can do with these rules. Instead of just replacing one color with another color, we could edit them over time. So here we're just saying that whatever color we put down, we're reducing the red, green, and blue values of every single frame. And we could change that to say, oh, we're only going to reduce the red, and we'll leave behind all the green and blue. And by combining these two ideas together, you can make some more wacky-looking things. I tried to make a sort of water drop system. And here's some lightning. And like you can see, this is just 3 spatial rules. There's no sort of written text code. It's all just spatial relationships. Okay, so now, so that was like the warm-up. And now I want to show you the main idea behind this. Okay, so can you see this rule in the top left? So instead of just replacing this blue cell with one other cell, can you see what we're doing? We're replacing this cell with 2. And this is the main idea behind this, that this grid is not fixed. We can split cells apart or we can merge them together. So watch what happens when I place down some of this blue. Can you see that it's actually splitting apart? And we can just keep going like further and yeah. And this will eventually this will eventually crash a computer. But I think it's quite a powerful idea, and I'd love basically more and more people to explore this idea too, because look at this. Okay, so in this example, that same shape, the red and green, I've got one rule here that just means it moves forwards into an empty space. So if I place them down, they all move to the right, right? So this rule is flipped in all directions. So I could place one down that's kind of pointing upwards, or I could like flip it round and place some down that go downwards. I could even add a rule that makes them randomly change direction. And this like storing a direction value is one of the main things that I always had to resort to traditional programming for. But if I pause it and I zoom in, just by looking at this picture, I can see what direction it's storing in it. And I think we can store lots more data just by drawing pictures. And I think that's a really accessible and fun idea. But this isn't the most interesting thing you can do with splitting. So the most interesting thing you can do with splitting is when you make a cell split into more copies of itself. So I just want you to have a think. Have a look at this rule. What do you think it's going to do? Whoa! Pause before it crashes. And so if you zoom in, this will just carry on going and going and going and going and going. But I mean, coding fractals can be hard. This is a fractal. It will have infinite detail. It will just keep going on forever. But it's just done with one simple spatial rule. And I think we can help more people to have fun with these ideas and understand them if we just present them in a more spatial way like this. And the great thing about this is I can just interact with it and add more wherever I want. Or I could say, actually, I want to try this fractal in a different shape. And yeah, I'll try it like this instead. And we've just made an entirely new fractal. There's been no words spoken, but it kind of makes sense to me, at least. And we can just place down more. Okay, I've got one more example, and then it's the end. So, oh yeah, there's one thing I want to say about this one. If you don't like the resolution that I've chosen for the grid, that's fine. You can just make a rule that splits every cell into like 4 more. Or you can keep going, but I don't want it to. We've got this far and there's been no crashes. Okay, so I'm just going to leave that going. So I guess my main point behind all of this, if you haven't been able to pick up, is I think this kind of spatial programming is really fun and exciting and accessible, and it just makes sense to me, so it might make sense to other people out there too. And I just want to give out this plea and this call for more people to explore it. If you found this inspiring or exciting in any way, then please, I don't know, give it a try. What's your take on it? Like, I'd love for you to reach out or contact me or contact a lot of the other people involved in this. And thank you very much. The next card.
Brilliant.
Thank you.
Very energetic and inspirational. We've got a couple of minutes for questions.
Oh, yeah, sure.
We, yeah, we'll go, yeah.
No.
Any questions, anybody? Anybody hands up there? Oh.
How much boring typewritten code did you have to write?
So much. Okay, no, so I do really enjoy, handwriting code. And yeah, but when I do that, I like to do it by choice, not because I have to. Yeah, this specific example is, this engine thing is probably like the 3rd or 4th version, and it still feels like a complete mess. It's one big file. The whole thing is about something thousand lines. But as a matter of pride, I'm keeping it all as one file for now. Yeah, thanks.
Oh, brilliant. One quick question, and we
Yeah, sure.
try to wrap up. Yeah.
So currently these days kids are using Scratch, and it's a very popular block-based programming. But I see the same problem, like after Scratch they move on to like Python or whatever other language, but it immediately becomes all this text, which because they have been able to make animations and games and really fun with music in Scratch, and now to do something similar, it takes a lot more effort. So there is, I feel, this gap, and there's nothing to bridge it because it feels. So what do you think of that problem? Because that problem doesn't seem to be solved yet.
Yeah, no, I completely agree. So my background is I used to be a primary school teacher for children with additional needs, and I taught a lot of Scratch lessons, and and I've encountered that issue so much of the time. So as children lower down in the school, they learn Scratch. Higher up in the school, they learn Python, and it's a bit of a reality check. And I kind of went through this reality check as well when we did Stage Cost Creator back in the day. And I've actually in last year I spent 9 months working with a good friend of mine, Max Bitka, and we tried to make one of those stepping stones between Scratch and a more advanced language called Sandspiel Studio, and it's certainly not a solution, but it's been really amazing. So basically, and it uses a block-based language like Scratch, but it's in a slightly more advanced and sort of less child-focused environment, and it's been very amazing to see what people have made in it, and it makes me think that I really want to put more powerful tools in the hands of young adults and children. There is so much more to do there. With this and with those block-based languages, I guess with CellPod, the idea is not necessarily to teach someone how to program. Maybe the idea is I would just like to help people to reason about these kinds of like data structures. Like, so, we could say this is a 2D array, like this grid. And maybe this doesn't help you to write that written code, but maybe it will help you to see how data and programs work in a different light. So it's certainly not meant as a replacement, but for me, thinking about data in this way has helped me as an adult. So, maybe it could help others too. Everyone works differently though, but it's a really good point, and like if you find out how we can bridge that gap, please let me know. Yeah, thank you.
Awesome. Thanks, Lou. Right, before we head to the pub, firstly, thank you all for joining us. Thank you, Tom, and everyone else who's helped with the technical side of things. B and Matt for hosting us and putting on Tech and Digital. We've now got about 45 minutes to join the artists at the exhibition. So just follow them out that door when we're all done. We've got to be out of here by 9, pretty much on the dot, and then we go to the pub. If you've entered the raffle, stick around for a minute. Johnny will.
I've just run the data now.
He just signed the data. So if you're not entered the raffle, go and enjoy the exhibition. Thank you.